Good day, this is Roniel Garcia and I'm with my group mates, Lady Ann Tabiolo, CJ Maglalang, Josabel Kapingian, Macho Dulnuan, and Kimberly Pinami. So today, we're going to talk about the wind turbine. So, wind turbine. Siya yung gumagana yung wind turbine. Yung itsura niya pag umiikot. Medyo malaglang. Next, let's take a closer look sa wind turbine. Itong kita na to, tawag dyan is rotor. Rotor yan, rotor. Tapos ito naman yung blade. Ngayon yung blade na yan, nakalagay siya sa hub. Then nilalagay niya yan hub. So ito nga sa likod, tawag dyan is nozzle. Nozzle yan. Tingnan natin yung nasa loob ng nozzle. So ito yung low speed shaft. Ito yung gearbox. Ito yung high speed shaft. At ito yung generator. Tapos lahat yan interconnected yan sa blades. So ito yung itsura ng loob niyan. Pag umikot yung blades, pag umikot yung blades, since interconnected tong laman ng nozzle dun sa blade, pag umikot yan, syempre ikutin nyo sa loob ng nozzle na yan yung low speed shaft, yung gearbox, high speed shaft, at saka yung generator yan. Tapos itong triangle na to, tawag dyan wind vane. So wind vane is used to detect the wind direction. Kaya ito naman tatlong bilog na to, umiikot din yan tawag dyan anemometer. So anemometer is used to measure the wind strength. The wind turbine is a type of renewable energy that harness the power of wind to produce electricity. So, the basic idea is that wind turbine uses rotor with attached blades to collect wind's potential and kinetic energy. Wind turns the blades, which spins a shaft that is connected to a generator, which results in generation of electricity. So a large number of wind turbine is usually called the wind farm. So ito pa ibang parts na wind turbine na hindi nasabi kanina, itong tawag dito yaw mechanism, brake yaw drive, yaw motor, tsaka yung tower, yung mismong pole. So yun nga, pagka interconnected nga kasi itong laman ng nozzle yung sa may blades. So pag umikot yan, ikot din to, tapos hindi magsisimula yung mag-generate yung electricity. So next, so wind turbine parts and functions. So sa blade, the blade is a part that rotates due to the force it catches from the wind. It is connected to the low speed shaft via the hub. The low speed shaft is connected to the gearbox and the gearbox to the generator. Once the blade rotates, it causes the rotation of the generator, thereby generating electricity. Most wind turbine consist of 3 blades for maximum efficiency. So yun nga, sabi nga, pag umikot na yung blades na yan, interconnected nga itong laman ng nozzle, ikutin niya, mag-generate ng electricity. So yun naman yung sa wind turbine, sa blade. Ngayon yung blade, sabi nga, the longer the better. Bakit? Dahil mas nakaka-capture niya yung kinetic energy na galing sa hangin kapag humangin.
Blade design. Airfoils is the cross-sectional shape of the blade that determines its aerodynamics. They are key to blade design. These airfoil designs allows the blade tips of the wind turbine to move faster than the wind is moving, thus generating more power and higher efficiency. Airfoils are cross-sectional shapes of wings, blades, or other aerodynamic surfaces designed to produce lift or thrust when exposed to air or other fluids. In this context of wind turbine blade design, airfoil plays a crucial role in determining the performance and efficiency of wind turbine. A wind turbine blade is essentially an airfoil that harnesses the kinetic energy from the wind and converts it into rotational energy to drive a generator. The shape of the airfoil is carefully designed to optimize the lift and drag forces, allowing the blade to extract minimum energy from the wind. Here are some key characteristics of airfoils used in wind turbine blades. First is the chord length. The chord length is the distance between the leading edge or the front and the trailing edge or the rear of the airfoil. It is a crucial parameter in determining the overall size and geometry of the blade. Next is the angle of attack. The angle of attack is the angle between the chord line of the airfoil and the direction of the oncoming wind. The angle of attack affects the lift and drag forces acting on the airfoil. Next is camber. Camber refers to the curvature of the airfoil. Airfoils with camber have a curved shape, and this curvature influences the lift characteristics. Next is thickness. The thickness of the airfoil is the distance between its upper and lower surfaces. It impacts the structural integrity and weight of the blade. Next is twist. Wind turbine blades often have twist along their length. This twist helps in optimizing the angle of attack along with the span of the blade, ensuring efficient energy extraction under varying wind conditions. Designing an efficient airfoil involves a trade-off between lift and drag. Engineers aim to maximize lift to generate more power while minimizing drag to ensure the overall efficiency of the turbine. Computational tools and wind tunnel testing are commonly used in design and optimization of airfoils for wind turbine blades. Blade aerodynamics. Wind turbine blades work by generating two aerodynamic forces, lift and drag. This is due to the wind and their airfoils. In the next context of wind turbine blade design, aerodynamics focuses on the principles of lift and drag to optimize the performance of the blades in capturing and converting wind energy. Let's delve deeper into these two fundamental aerodynamics forces. First is the lift. Lift is the force that acts perpendicular on the oncoming flow of air. It is a force responsible for elevating the wind turbine blade. Lift is crucial for harnessing the kinetic energy from the wind. Wind turbine blades are designed to generate lift as the wind flows over and around them, causing the blades to rotate. This rotation is then converted into electrical energy. Next is the drag. Drag is a force acting parallel on the oncoming flow of air. It resists the motion of the object through the air. While lift is necessary for the rotation of the blades, excessive drag can reduce overall efficiency of the wind turbine. Engineers aim to minimize the drag to ensure that the majority of the aerodynamic forces contribute to rotational motion rather than opposing it. There are key factors influencing lift and drag. First is the angle of attack. The angle between the chord line of the airfoil or the blade cross-section and the oncoming wind. The angle of attack significantly influences the lift and drag forces. Engineers optimize this angle to achieve the desired balance for efficient energy extraction. Next is the airfoil shape, the specific contour of the wind turbine's blade's cross-section. The shape of the airfoil is critical in determining the lift and drag characteristics. Engineers carefully design airfoils to maximize lift while minimizing drag to enhance overall efficiency. Next is the Reynolds number, a dimensionless parameter used to predict transitions between laminar and turbulent flow. The Reynolds number helps in understanding the flow conditions around the blade. Engineers use this parameter to optimize the aerodynamic performance of the blades. Next is stall. Stall occurs when the angle of attack becomes too high, leading to a sudden reduction in lift. Engineers work to prevent or control stall, as it can decrease the efficiency and stability of the wind turbine. Proper design aims to delay stall and maintain an optimal lift. The lift and drag forces on the wind turbine blade can be expressed using the lift and drag formula along with the dynamic pressure of the wind. First is the lift force, where L is the lift force, C subscript L is the lift coefficient, rho is the density of the air, V is the velocity, and A is the reference area of the blade, or the area of the wind turbine blade perpendicular to the wind. Next is the drag force, where D is the drag force, C subscript D is the drag coefficient, rho as the density of the air, V as velocity, and A as reference area, or the front side of the blade that's being hit by the wind. It is important to note that lift and drag formula are dimensionless values that depends on the geometry and characteristics of the airfoil or the blade section. These coefficients are typically obtained through wind tunnel testing or computational simulations for specific airfoil shapes. Blade aerodynamics. Difference in pressure. Most curved side is equals to low air pressure, and the less curved side is equals to high air pressure. The difference in pressure on the surfaces of the wind turbine blade is a key factor in understanding the aerodynamics of the blade and consequently the generation to the lift. The concept is closely tied to Bernoulli's principle, which states that as the speed of such as air increases, its pressure decreases. In the next context of wind turbine blade, the difference in pressure between the upper convex and the lower concave surfaces is crucial for generating lift. Here's how it works. First is the upper surface or the convex. As the wind flows over the upper surface of the blade, it has to cover a greater distance compared to the lower surface due to the curvature of the airfoil. According to Bernoulli's principle, the air velocity on the upper surface increases, leading to decrease in pressure. Next is the lower surface or the concave. The lower surface of the blade is usually curved differently, creating a shorter path for the wind to travel. The air velocity over the lower surface is lower, resulting in a higher pressure compared to the upper surface. Now, what is the pressure difference? The pressure difference between the upper and lower surfaces creates a lifting force known as lift. This force is what causes the wind turbine blade to rotate. In summary, the difference in pressure on the upper and lower surfaces of the wind turbine blade, as governed by Bernoulli's principle, leads to a generation of lift. The lift force is essential for the conversion of wind energy into rotational motion, which is then used to generate electrical power in the wind turbine.
So, next naman punta naman po tayo sa wind orientation. Blade wind orientation. Which part of the blade is the leading edge and trailing edge? Which is the front side and the back side? So, as you can see in this figure po, this is the leading edge and this is the trailing edge. And tilted na dito ang airfoil, kaya ang wind direction yan is pag ganito, or horizontal. Sabi nga nakasama ko kanina, maraming design ng airfoil. And this one is an example of an airfoil. So, makikita natin dito ang leading edge and trailing edge. Kailangan malaman natin kung saan mas nakaharap ang hangin sa isang airfoil. And to know that, we first need to understand the optimum angle of attack. The optimum angle of attack. The optimum angle of attack is how the blade is being tilted in accordance with the wind direction. The angle depends on the blade design and the wind speed. If the angle is too high, the airflow will separate and reducing lift. And if it's too low, it will not utilize the power of the wind. So, kailangan natin mahanap ang optimum angle of attack. Kasi, it is the key to a efficient wind turbine operation para ma-maximize nito ang rotation ng blade. So, looking at this figure, saan nga ba mas nakaharap ang blade sa hangin? So, kung dito ang tama ng hangin, makikita natin na ang tama niya ay sa less curve ng airfoil. Papunta sa more curve. Ganito kasi ang orientation hangin yan. Tatama sa less curve, pupunta dito, and mag-flow papunta doon. Mag-flow papunta doon. So, mas nakaharap ang less curve. And madaming design ng airfoil, kaya minsan, mahirapan tayong ma-identify kung saan nga ba ang less curve sa more curve. At makikita natin sa more curve, sa more curve makikita natin na ito ay convex, paumbok dito. Paumbok. At sa less curve naman, medyo trailing edge na to ay slightly concave dito. Ito ang less curve, medyo concave dito sa part na to. So, sa less curve tatama ang hangin. So, mas nakaharap ang less curve. Next question. Blade rotation. What will be the rotation of the blade? So, saan nga ba tatama ang hangin? So, looking at this figure, sinabi nga ng kasama ko kanina, the movement of air is from high pressure to low pressure. So, first na tatama ang hangin sa less curve and pupunta ito sa more curve. So, high pressure pushes the air from high pressure pupush na yung blade papunta sa low pressure. So, tatama sa less curve, papush sa more curve. So, understanding this, pag nakita tayo ng wind turbine, malalaman natin kung saan umiikot ang blade na to kapag nakita natin kung saan mas less curve. Kasi, doon nagbibuild ang high pressure at pupunta lang at pupush nito papunta sa low pressure kung saan mas more curve. So, next is blade wind orientation. So, understanding and the previous discussion, sinabi ko, malalaman natin kung saan ang backside and front side ng isang wind turbine. And malalaman din natin ang leading edge and trailing edge. So, next naman is blade design. In addition to its curves design, twisted and tapered blades further enhances aerodynamics. With the combined effect of twisting and tapering the blade along its length, improves the angle of attack, increasing speed, efficiency, and lift while reducing drag. So, hindi lang pala curve ang nagpapabilis ng isang blade. Twisting and tapering din. Sa latter part, tinitwist ang isang blade or sa hulihang parte ng and tinitaper nito ang mga edges para mas mabilis ang pag-ikot ng blade. And ito, isang type to ng blade design. Ang importante lang sa pagbibuild ng blade design, kailangan mong ma-reduce ang drag at ma-reduce ang drag and to improve the lift. In doing that, mas mapapabilis ang rotation ng isang blade. That is all.
Let's talk about the number of blades. And here is the question. Based on the previous slide, what number of the blade is the best design in consideration of all the factors in construction and operation of wind turbine? Madali na lang natin masasagot ito kung ilan ba talaga dapat ang best number ng blades ng isang wind turbine. 3 blades kasi halos gano'n naman ang nakikita natin na ginagamit ngayon sa lahat ng wind farm. Pero ipaliwanag natin kung bakit pinaka-dapat gamitin ang 3 blades wind turbine. We've already known that the rear of the blade is curved more than the front. This varied shape causes the pressure differential when the air moves across the blade, which is the causes the blades to move. Because of the obstruction of the blade, air moves at a faster velocity behind the blade than in front of it. This is what sets the rotation of the blades in motion. Being an engineer, what should be considered to ensure the highest level of efficiency? Engineers must consider speed and drag in designing the blades. For example, if too much drag is created by the obstruction of the blades, the power yield will be a lot lower. If not enough drag is created, the blade could move too quickly, causing them to break the sun barrier. In summary, in designing the blades, the one that should be minimized is the drag force, and the one to be maximized is the lift force. Next is the rule of thumb. The rule of thumb are the fewer the blades, the better. Since there will be less drag and an increase in efficiency, the more na marami ang blades, mas lumalaki ang drag force. Kaya the fewer blades, the better. Mas konti ang blade, mas mababa ang drag. Ito nga yung gusto nating pababain pag nagde-design ng blade. Next is the number of blades, increases the torque and reduce the optimum rotation speed. Ibig sabihin, the more na mas nadadagdagan yung blade, mas babagal, pero mas lalakas. Yun yung ibig sabihin ng increase the torque, mas lalakas. Third is having fewer blades, reduce drag. This is the same in the first rule of thumb. And now let's talk about why 3 blades are the best design of all. Here is now the question. Which one rotate faster under the same circumstances? 1 blade or 3 blades? So gaya nga ng na-explain kanina, the one that will rotate faster under the same circumstances is 1 blade. Simply because the fewer the blade, the lesser drag. So ibig sabihin, pag mas less ang drag, mas mabilis ang magiging rotation. 1 blade. Because of the decreased drag, 1 blade would be the optimum number when it comes to energy yield. Pero ito ang issue. However, 1 blade could cause the turbine to become unbalanced. Yes, there will be too much unbalance while it is operating, and this is not practical choice for the stability of the turbine. Next is the 2 blades. At first glance, 2-bladed turbines seem like the optimal configuration for a wind turbine, perfectly balanced, and with 1 blade less than a 3-bladed turbine, they will generate less drag. So why aren't all made with 2 blades? Pero here is now the big issue when it comes to the operation of 2-blade turbines. It has trouble in yawing. Ano nga ba yung yawing? Yaw is when its head for nacelle turns to face the wind. Ibig sabihin nito, hindi nakafix yung nacelle ng wind turbine. The whole wind turbine itself should follow the wind direction. Dapat lagi siyang nakaharap sa direksyon ng hangin. Siyempre, pag nagbago ang direksyon ng hangin, dapat susundan niya yung ikot ng nacelle. Yung pag-ikot ng nacelle na yon para sundan yung hangin, ang tawag doon ay yawing. And when the 2-bladed turbine yaw, it becomes bubbly due to an effect called gyroscopic precession. When the 2-bladed turbine yaw, it creates a wobble as the blades go from the vertical plane to the horizontal plane, which places additional stresses on the mounting bearings, wearing them down faster. More than 3 blades. Any number of blades greater than 3 would create greater wind resistance. Kasi nga, the more blades you add, the more you increase the drag force. Therefore, it will bring down its efficiency, slowing the generation of electricity and thus becoming less efficient than a 3-bladed turbine. That is why pinaka the best talaga ang 3-bladed wind turbine. 3-blade. For this reason, turbines designed with 3 blades are the ideal compromise between high energy yield and greater stability and durability of the turbine itself. Ano ba ang function ng blade tilting mechanism? According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a sensor-coupled parts of the wind turbine which tilts the blades and guarantees alignment of the blades with deity so that its position is always at the optimum angle of attack. Next is the nacelle, the house at the back of the blade, which contains the slow-speed shaft, gearbox, generator, and other small parts inside it. Sapat ba yung ikot ng blade para paikutin yung generator at makapag-produce siya ng grid quality voltage? Ang sagot, mostly hindi. Ano naman ang magiging function ng gearbox? Yung mabagal na ikot ng wind turbine, pabibilisin ng gearbox. The component which converts the slow rotation of the blades into faster speed. It is needed simply because the rotation of the blade generated from the force of the wind is usually not enough for a generator to achieve a grid quality voltage output. Most generators need to be turned at 1,500 RPM for 50 Hz and 1,800 RPM for 60 Hz. In no way it is feasible for a turbine blade to move that fast. A common ratio is about 90:1. When the blade rotates once, the gearbox will rotate 90 times already, with a rate of 16.7 RPM input from the rotor to 1,500 RPM output for the generator.
I'm CJ Maglalang. Ngayon, pag-uusapan naman natin ang alternative design ng wind turbine, which is yung tinatawag natin na direct drive. or gearless wind turbine. Bagong lahat, papakita ko muna sa inyo itong short clip kung paano siya nag-ooperate at kung ano yung design niya. Halos same lang naman din siya sa gear type. Sa susunod na mga slides, papakita ko sa inyo kung ano yung pinagkaiba niya. Wind turbine direct drive. In a direct drive turbine, there is no gearbox. The main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. Comparing to gear type, the slow rotation and decrease in moving parts of gearless generator reduces fatigue and stresses on the turbine, resulting to reduced noise and vibration, longer lifetime, and lower cost of maintenance. Bali dito sa direct drive, ang kaibahan niya dun sa gear type, mas yung noise reduction dito, mas okay kaysa dun sa gear type. Tsaka yung vibration, wala siyang ganong vibration. Tsaka pang matagalan to. Tapos kung sakaling ito yung gagamitin, hindi ganon kalaki yung or hindi ganon kataas yung cost ng magiging maintenance ito kumpara sa gear type. An important fact is that due to wind inconsistency, the gear type turbines often operate at partial loads. The efficiency of the direct drive generator excels even in these conditions because it continues working nearly to nominal values. This design makes suited even in offshore with application. Kung makikita natin, ito yung parts ng direct drive. Halos same lang siya. Ang pinagkaibahan nga lang is yung wala na tong gearbox. Di katulad dun sa gear type. Tapos yung gamit dito is yung permanent magnet. One main disadvantage of direct drive is that to make up for its lower rotation, more magnets are added to create the required frequency and power. This increases the diameter of the generator, which makes it larger and often heavier than gear type wind turbine. Another thing is that the additional magnets being used in this type is made up of neodymium, which is expensive. The cost and weight of the direct drive turbines have prevented it from presenting major competition to the gearbox turbines until recently, but other experts claim that direct drive technology will eventually become the dominant one. Since the gearbox wind turbine is almost at its maximum efficiency point, while the direct drive generators have more possibilities for improvement. Kung makikita natin dito, itong malaking bilog na to, ito yung pinaka-generator ng direct drive. Mas malaki siya, hamak ang laki nito kaysa dun sa gear type. Tapos, marami pang pwedeng i-improve dito sa direct drive. Once naman na na-improve yung mga possibilities, mas magiging okay siya kaysa dun sa gear type. Ito naman yung types of direct drive gearless nakita natin sa internet. Ito yung technical data tsaka yung advantages at a glance. Ayan siya. Dito naman yung comparison ng gear type sa gearless. Yun nga, gaya ng sabi natin kanina, yung gear type, meron siyang gearbox, which is, yun yung nagpapabilis sa ikot ng blade. Ang ratio niya is 1 to 90. Isang ikot ng blade, bali nagiging 90 times. Dito naman sa gearless, kung ano yung ikot ng blade, yun natin yung ikot ng generator. Pero para mas maraming voltage yung mai-release niya or maibigay, kailangan natin ng maraming magnet, yun nga, sets of magnet.
So let's continue. Wind turbine, win-win solution to generate electricity. Dako tayo dito sa tower and blade ratio. Sa evolution nito, mapapansin po natin na from 2000 to 2005, mas malaki yung kanyang average height ng tower compare sa kanyang rotor diameter. And then, pagdating sa 2010 up to present, palaki na yung kanyang rotor diameter compared sa kanyang tower. And then, according to engineering knowledge and application, mas malaki yung kanyang rotor diameter, mas malaki yung nasasapon niyang hangin, or mas malaki yung tendency niya na makapag-produce ng greater amount of electricity. And then, mas less yung gagamitin niyang gastos para makapag-install ng isang wind turbine. And then, mas magiging efficient pa siya. Mas efficient siya compared sa previous year na from 2000 to 2005. Next, dako po tayo dito sa advantages ng wind turbine. First, wind is free and fuel free. Hindi na natin kailangan magsunog pa ng fossil fuel o hindi na natin kailangan gumastos pa since masyadong mahal din to. And then also, hindi rin habang buhay meron tayong mapagkukuhanan ng fossil fuels. And then, ang kailangan lang natin dito to produce electricity is yung hangin from aerodynamic force. Yan. Then next, it produces no waste or greenhouse gases. Hindi siya nakakapag-contribute sa air pollution. Hindi siya tulad ng fossil fuel na sa pagsusunog nito is malaki yung contribution niya sa greenhouse gases, also sa global warming and sa climate change. Malaki yung effect ng paggamit ng fossil fuel. Then, the land beneath is also pwede pa rin siyang magamit sa pag-farm, and it is also a good method of supplying energy to remote areas. Next po natin. Ako naman po tayo dito sa disadvantages. Ayan. Wind is unpredictable. Hindi natin, yung speed ng wind is, hindi siya continuous 24/7. I mean, hindi siya yung continuous na, merong average na, I mean, meron siyang continuous na, halimbawa, ang hangin ngayon is 40 km/h. Hindi siya palaging ganun. Nagbabago-bago siya. Minsan mahina, minsan malakas. Ganun. And then, suitable areas lang to sa mga malapit sa coastal area or dun din sa malapit sa bundok o sa baba ng bundok. Kung saan yung lugar dito is sobrang mahal. And then, naapektuhan din yung signal ng television, phones, and others. Then, dako tayo din sa largest wind farm. Ang nangungunang wind farm na meron dito sa mundo is ang Gansu Wind Farm na mayroong capacity na 7,965 and still continue to expand na may target na 20,000 capacity na megawatts. 20,000 megawatt capacity rather na matatagpuan sa China. And then the second one is Alta Wind Energy Center na mayroong 1,548 megawatt capacity and still continue to expand which has a target goal na 3,000 megawatt capacity na matatagpuan naman sa California, USA. Next is Mapundal Wind Farm na mayroong 1,500 megawatt capacity na matatagpuan sa India. Hornsea Project 1 na mayroong 1,218 megawatt capacity na matatagpuan sa UK. Mark Biggen Wind Farm na mayroong 1,120 megawatt capacity and still continue to expand sa target goal nila na 4,000 megawatt capacity na matatagpuan sa Sweden. And then, Heiselmer Wind Park na mayroong 1,064 megawatt capacity na matatagpuan din sa India. Additional knowledge lang na dito sa Mark Biggen Wind Farm na about 75% state yung pag-aari nito is nasa China na. Nagkaroon sila ng bankruptcy. Ayan. Let's continue. Sa largest wind farm in the world, tagpuan sa China. Ito. Gansu Wind Farm Project or Jiaoquan Wind Power Base. Ito yung pinakamalaking construction ng pinakamalaking wind farm sa buong mundo. And yung kanyang image. Sobrang dami talaga. And then, started to noong August 2009. Nagsimula yung construction nito noong 2009 and then officially announced na natapos na yung unang phase nito noong 2010 na merong 3,500 wind turbines na installed na merong installed capacity na approximately 5,160 megawatts. And then merong estimated cost na 120 billion Chinese yuan or 17.5 billion US dollar. And then the project is being built by more than 20 developers. Ayan, ang target wind turbines nila is about 7,000 wind turbines na itatayo nila. According din sa sinabi ko kanina na sa previous slide na ang target nilang capacity ay 20,000 megawatt kapag natapos na to. And then, next. Ano naman kaya ang largest wind farm in Southeast Asia? Ano naman kaya ito matatagpuan? Sa Philippines. Ayan. Burgos Wind Farm. Merong itong 150 megawatt capacity at ito ay tinagurian din na pinakamalaking wind farm in the Southeast Asia na matatagpuan to sa Burgos, Ilocos Norte, Philippines. Also, naging tourist spot na rin ito sa atin. And then, ang estimated cost nito sa pagbuo nito is 450 million US dollar na natapos noong 2015. And merong 600 hectare site. And then, meron siyang nakatayo na 50 wind turbines and may capacity na 3 megawatts and it's generating electricity to Luzon grid. And each wind turbine, meron siyang 75 meter yung tower niya or yung hub height niya and then 90 meter rotor diameter niya. Ayan, mas updated na siya, upgraded. Hindi siya katulad ng sa sinabi ko ngayon na average ratio niya na from 1,000 to 1,005. Mas malaki na ngayon yung rotor diameter niya and mas malaki yung efficient niya, mas malaki yung chance niya na makapag-generate ng mas greater amount ng electricity and then mas less pa yung kanyang gasto sa paggawa nito. Then additional knowledge lang, according sa Philippine Department of Energy, na nag-set sila ng goal na mag-add pa ng about 2,870 megawatts by the incoming 2030. Yan. Ngayon, paano nga ba tayo nakapag gamit ng energy or ng electricity gamit sa wind turbine or yung sa pamamagitan ng wind turbine? Ayan. So, syempre, from wind, kapag humangin, yung rotor blade niya is iikot. Nagkakaroon siya ng air pressure differential which is yung lift. Yung lift niya is mas malaki compare sa kanyang drag force. And then kapag nangyari yon, humangin, syempre iikot yung rotor. And then from rotor, from rotor blade, dediretso siya sa gearbox. Then pagdating naman dito sa gearbox is mas pabibilisin pa niya yung ikot niya na i-deliver sa generator. And then from generator, nakakapag-produce tayo ng electricity. Ayan. Ang tawag sa pag-produce ng electricity gamit ang wind is the ang kailangan lang natin doon is aerodynamic force. Or yung nangyayari din to sa sa lift, sa airplane wing. 'Di ba from doon pagka tamaan siya ng hangin and then nagkakaroon siya ng lift. Yan, nagkakaroon din siya ng air pressure differential rather. And then from generator, pupunta naman siya sa power cables inside the tower. And then goes to transformer. And then from transformer, wind farming uses a setup transformer to increase the voltage at tapos pabababain niya yung current para mabawasan yung power loss. Nangyayari ito kapag nagtatransmit ng larger amount ng current sa pagde-deliver sa malayong lugar. Kasama nito yung ng transformer ay yung transmission line cables para makapag-deliver ng larger amount electricity sa community. And then from here, pupunta naman siya sa substation. And then, pagdating doon sa substation, kapag na-reach na niya yung community, yung voltage sa may transformer, nababawasan na para magkaroon ng safe and usable electricity para sa consumer. Mas ligtas. At mas ligtas, mas efficient, and mas mura. Ayan. So, thank you for listening. Have a great day, everyone.